Welcome to 7-1, and we are looking at slope fields today. And slope fields is a topic we had last year. Let's just see what you remember of it. Oftentimes, they'll give you a slope field or they'll have you draw your own slope field. Also, the separable differential equations often come in with the free response question dealing with slope fields. So we'll just take a look at, there's 4 questions on the assignment sitting in your notes. I think we'll do 1 and 2 together today. Yeah, we'll do 1 and 2 together today, and then you can finish up 3 and 4. So this first one is not an easy one. It says, which of the following differential equations would produce the slope field shown below? And when I look at these slope fields, I notice there's a lot of positive slopes in this one, mostly positive slopes too in quadrant 4, mostly negative in quadrant 2, and looks like mostly negative until we get over to the right where we start getting flattened out. So sometimes those observations can be helpful because I can think about the XY, that this is positive, positive, and be able to see, like, if I had X times Y, well, then that should end up being all positives in quadrant 1. If I had X times Y in quadrant 2, well, then I know I should have all negative slopes. So sometimes when you have multiplication, it becomes very easy to detect what the correct answer is. Or if I had some very easy zero slopes to pick up, like when X is 0 here, would the slopes turn out to be 0? I'm not seeing any real obvious ones to check on this particular problem, so I think I'm going to just kind of work left to right thinking this one through. So I get y minus 3x. If I pick just a point, and I don't know exactly the scale on this, that's another, problem here, but if I just thought about 1, 1, which would have to be somewhere close to the origin, I'd have 1 minus 3, and that would give me a negative slope. And I don't see anything that resembles a negative slope right in quadrant 1 close in on the origin. And that leads me to believe then that, or even as I move out in here, that this is not a valid answer. So I've got A marked off. For B, I get y minus a third of x. You also may just even want to convert this to 3 times y minus x. That might be easier to think of it that way. Well, if I use that 1, 1 idea here, I'd have, 3 minus 1? That would be positive, so that stands okay. What if I moved way over to the right side, maybe thinking like a 1, 6 going in there? I'd have 3 minus x, 3 minus 6. Well, that's going to give me a negative, and it clearly looks like as we move to the right, we have even stronger positive slopes. So for that reason, I'm going to block off B as well. Moving into C answer, that would convert to a 3y plus x over 3. And if I used 1, 1, that would be a positive slope. If I used 1, 6, that's a positive slope. It looks like, what if I used like 1, well, even let's go at 0. 0x, 6 for y. So as I'm moving up the y-axis, will I get some negatives? Because I see this negative coming in. And if I'm on the x-axis, that removes the x variable there. So it's solely based on y, and y's are going to be positive as I move upward. So there's no chance I'm getting that negative slope that's showing. So for that reason, I'm eliminating C as my option. Let's move on to D. This is a slowpoke way of doing this, and maybe you see something that's not jumping out at me, but some of these are kind of meticulous. All right, 3x plus y. Once again, I think you can kind of reason out right there. If I had 0 and a 6, I should not be getting a negative. And any y value is going to be positive above the x-axis there. So I'm not liking D either. Okay, let's hope E works out. So I get 3x minus y over 3 if I make it into one fraction. If I like this. If I put in that 0 again for x and a positive for y, and I move up the scale, I do start getting some negatives. So that holds true. If I go far enough over, get a large x, well, it's always going to overpower the y, isn't it? Because it's going to be 3 times as big as y. I'm kind of liking that. It's going to stay positive. Yeah, I'm pretty convinced E is my answer. Those can be tricky and tedious. Number 2 can be tedious too, because now they're asking you to put in the slope fields. On the axis provided at the right, sketch a slope field for the given differential equations at the 12 points indicated and for -1 to 1 for our x values. Sketch the solution curve that passes through the point 0, -1. So what we got to do is get our slope field locked in on this and then draw the solution curve. I'm not going to do them all. Thank you, huh? So there's 6 up there. This would be the point 1, 1. So if I put 1, 1 in, I'd have 2 over 1. I need a pretty steep slope. A 2 over 1 slope, something like that, up to over 1. So I'm going to try and mimic that running parallel to that slope of 2. What about 1, 2? If I put 1, 2 in, I'd have 1 plus 1 over 2, so that's a slope of 1. And, so on. So 0, 2, 0 over 2, I would have 1/2, even slighter. 0, 1, put 0 in for x and 1 in. We'd have a slope of 1 again, which should match right with that one, and so on. So you can fill in the rest of that field. I'm going to pause for a moment, and I'm going to try and sketch mine in. All right, I sketched in the rest of my slopes, and so I'm on this last part. Sketch the solution curve that passes through the point 0, -1. And if I had 0 for y, I get an undefined slope. So I'm just going to indicate that is open there, and I'm going to come through. It looks like my solution curve would be along there. I did point out that at these 2 precise locations, the slope was -1. So I just drew in a linear function for that. Part B, while the slope field in Part A is drawn at only 12 points, it's defined at every point on the xy plane for which y is not equal to 0. Describe all the points in the xy plane for which dy dx equals -1. This seems like a hard problem, but do some substitution. So they told us dy dx equals -1. I can substitute right there, correct? So I'm going to put -1 equals x plus 1 over y, and we're guaranteed that y is never 0 by that statement there. Now let's just try and solve and see what we come up with. I get y times that gives me -y equals x plus 1. And I got to describe all these points. So I'm going to describe it in an equation format by bringing the negative over to the other side. I'm going to get y equals -x minus 1. And that would be all the points along there. So describe all the points on the plane when dy dx. Yeah, so I think it's described by this linear function. Notice that our b-intercept is -1. The slope is a -1. Anything on that linear function basically describes I'm coming through there. Find the particular solution, y equals f of x, to the given differential equation with the initial conditions 0, -2. Right, I'm going to erase. What we need to do is I need to work with dy dx equals x plus 1 over y. This is the separable differential equation that we just left off with last section. So it's been a couple weeks since you guys have done this, but let's get through it. Separable differential equations. First step you'll always want to do is get your y's on the dy side, get your x's on the dx side. So for this particular problem, I'm simply going to multiply by y and bring it up. So I'm going to have y dy equals x plus 1 multiplied by dx. You can go ahead and plop your integral symbol on there. Now we're going to integrate both sides. That's going to be a 1/2 y squared equals a 1/2 x squared plus x plus c. We could go ahead and try to find, might as well. Let's find c. I was debating about multiplying by 2, but I think I'll just leave it here. Let's find c at the point 0, -2. So plugging in -2 for y gives me 1/2 of 4 equals 0 plus 0 plus c. So therefore I can see that x equals 2, or c equals 2. All right. Then we rewrite the equation, correct? I'm going to rewrite based back on this, that I have 1/2 y squared equals 1/2 x squared plus x plus 2. Now I can see that I very easily can multiply by 2. Let's do that. Get rid of the halves. That step's locked in. I got y squared equals x squared plus 2x plus 4. And find the particular solution. Notice how they say it's framed in y, and it's going to be in terms of x's. That's looking like that's going to happen. I would have plus and minus here as I take that square root. X squared plus 2x plus 4. Now, is it both solutions? Most likely not. Remember, it has to go through 0, -2, has to be on our solution curve. So if I put in 0, I'm going to have -2 has to equal 0 for x, and I get the square root of 4. But I need it to come out to be -4, which means my solution is going to be the negative radical version. Okay? So always be sure to double check whether it's positive or negative as your final answer. That leaves you just with 3 and 4 to figure out.